No smoking, no drinking, no vaping, no whatever else you people do. None of that. Just exercise and do math. The secret of a long life. Okay. Find the end behavior asymptote. Now, this was an issue in some of your homeworks. What should your answer look like? Y equals. Yeah, you're finding an end behavior asymptote. So for problem A, what will that end behavior asymptote be? Y equals 4/3. Now, if it asks for the actual end behavior, then you would be doing the limit and all that stuff, right? But that's not what this says. It says, what is your end behavior asymptote? All right, what about B? Y equals 0. Y equals 0. What about C? Exactly. Now, we're going to talk more about this today because I didn't talk about it the other day. But for C, when you cancel what you got there, would you agree that you have something like that? I don't know what the rest of the problem is, but it's going to start out as -3/4x. So this end behavior asymptote will be a slant asymptote, right? And it will have a slope of -3/4. All right, what about D? Its end behavior asymptote is going to look like 2x to the 5th, which, by the way, we're not going to graph anything with that kind of an asymptote, but what does a 2x to the 5th look like? It starts down here, does some bouncing around, and ends up there. So whatever freakish picture we get out of this, that would be the asymptote. So as the curve goes off the page, it's going to be mimicking that end behavior. But it would look like that. That would be the asymptote. And how about E? On top, I have -x squared. And on the bottom, I have 8x squared. Yep, so it would be y equals -1/8. That would be a horizontal asymptote. Remember, if the powers on top and bottom match, your asymptote will be horizontal. Y equals. If the denominator power is bigger, your asymptote's also horizontal. It's y equals 0. If the power on top is bigger, that's when funkiness happens, right? All right, find the zeros, vertical, horizontal asymptotes, holes, and y-intercept. Now, this is kind of review type stuff, but let's go through it. Make sure we remember all this stuff. Should I factor first?
Probably.
Yeah, I think I will. All right, double check my factoring before I move on. I really don't want to mess that up. Is that okay?
Yeah.
All right, what do you notice about it? We can cancel? What does that mean? We're going to have a removable discontinuity or hole in the picture. And where's it going to be? What did I cancel out? -1. -1. Now the hole is a point. any idea how to find the y coordinate? I know the x coordinate,
Plug in this.
it came from what I canceled out. But now I'm gonna put -1 in here. So I'm gonna get -6 over 2 times 1. Did you get -3? Is that all right? Now let's look at this. Do I have a vertical asymptote? Of course I do. Where's my vertical asymptote? Where? -2. X cannot be -2. X can't be -2. Because what happens if you put -2 in there? You get a 0 on the bottom, which is never good. Do I have a horizontal asymptote? Well, you can look at the original problem if you want, or you can look at this one. Do I have a horizontal asymptote? 1/2, y equals 1/2. How do we find a y-intercept? Alright, so I'm gonna have -5 on the top. I got -5/4 when I put 0 in. So that would be right here. What do we mean by find the zeros? What are the zeros? X-intercepts. So we're gonna let this be 0, let y be 0. Isn't my x-intercept gonna be at 5? And that's it, that's all the information. Do you think you could sketch it from here? Do you think you have enough to sketch? Alex,
Wait, how do we know that the x-intercept is 5?
solve this equation. The only way a fraction will equal 0 is if its numerator equals 0,
Okay.
right? Doesn't really matter what's in the denominator because it's gonna disappear when you start solving it. So the numerator has to be 0. So I have all those dots, I connected them, that's perfect. What's happening over here?
Exact opposite.
The exact opposite. Now, I know that's your gut feeling, that's your intuition, but how do I know for sure that it looks like that? Because couldn't it, remember this is my end behavior asymptote, couldn't it approach from the bottom, couldn't it look like this? How do I know for sure that it doesn't look like that? What would have to be right here? Another x-intercept, and how many x-intercepts do I have? 1. So I can't cross the axis over there, it can't possibly be that
Could you
in
also
this
just
problem.
plug in like a number like -5?
You
Yeah, check
absolutely
it.
could. Yep, you absolutely could. No need to, but you could, always. Plot more points, get better picture.
How did you find the horizontal asymptote?
Look at your original problem, x squared over 2x squared, right? All right, let's try B. B doesn't factor as much. So look at that. Are we gonna have any holes in this picture?
No.
Nope, nothing canceled, no holes. But we do have 2 vertical asymptotes. Would you agree with that? -2 and +2. Vertical asymptotes are cannot be's. X cannot be 2, X cannot be -2. Does this problem have a horizontal asymptote? Okay, let's make sure you remember our rules. If the power on top is smaller than the power on the bottom, your asymptote's gonna be 0, right? No matter what. No matter what the powers are. The big one's on the bottom, your asymptote's gonna be 0. Do I have a y-intercept? Well, let's see. What happens if I let x be 0? What do you get if you let x be 0? That's your y-intercept. You let x be 0. What do you get? 7/4. What makes this fraction equal 0? That's a 0. What makes it equal 0? There's only one number that would make that equal 0. What is it? 7/2. Now, this is where some of you might get nervous. Because what did I just do?
You put it on the asymptote.
I put a point on an asymptote. Alright, so we need to talk about this. You will never, ever, ever put a point on a vertical asymptote. Does that make sense to you? Vertical asymptotes cannot be. You are not going to touch a vertical asymptote, ever. But what is this? It's a horizontal asymptote, but where is it coming from? It's the limit as x gets really, really big. They're called horizontal asymptotes or end behavior asymptotes. So where are the ends? The ends are out here, right? These are the ends. Technically, it's not even an asymptote in the middle of the picture because the whole point of it is end behavior. So you can cross a horizontal asymptote as many times as you want in the middle of your picture. But as you go off the page, it's going to come in closer and closer to get from the top and the bottom.
So for a vertical asymptote, if like say the denominator was just x, and so your vertical asymptote would be on 0, and to ask for the y-intercept, you just say none.
None, because if your fraction looked like that, you cannot put 0 in there, so it would have no y-intercept. Okay, so what does this thing look like? I have no idea. But there's 3 parts to it. There's a left side, a middle part, and a right side. Anybody have a guess what the middle part looks like? What do you think it looks like between these 2 asymptotes? A parabola? And it's probably not an actual parabola, but it has a parabola type shape. How do I know that? Well, this is the only place I can cross the x-axis, right? Isn't that my only 0? So is there any way that I can be down here anywhere? I have to be all up there, right? So I really don't have any choice. It has to work like that. Out here, could I make the same argument that it's either looking like this or like this? Does that make sense to you? I really have no idea. There's no clues. So I think I'm going to pick a point. Maybe, what is that, -2, maybe -3? What happens if I put -3 in here? Does my answer turn out positive or negative if I put -3 into my fraction? Turns out negative. So if I put in -3, I get a negative. Doesn't that kind of mean that that's what my picture's going to look like? Remember, he's going to approach his asymptotes as he goes off the page. So whatever you draw has to get closer and closer to that horizontal line, and it has to get closer and closer to that vertical line. The curve will always approach its asymptotes as it goes off the page. What about over here? Let's try 3. That's 3 right there. If I put in 3, am I positive or negative? Negative, okay. So it looks like it's coming up like this. What about when I put in 4? Positive, so it's gonna come up. Now, don't do this. It comes up. We check the point, it comes up. But how do I know it doesn't do that? Because its asymptote, end behavior asymptote is 0. So at some point, not sure where, it's a calculus problem, I'm gonna come up and then come back down like this. Does that make sense to you? It crosses over, bubbles up a little bit, but eventually it has to come back down as it has to approach its asymptote. Interesting stuff. Okay, let's see what's on the next page. Use limits to describe the end behavior. All right, so now we are actually describing the end behavior. So, we're going to use our limits. All right, so here we go. Problem A. What do you think about problem A? What's happening on the ends of that picture? What's it heading toward? 3/4. And does it matter which direction I'm going? No. Probably if I were to graph it, one of them would be coming up, one would be approaching from the top, and one would be approaching from the bottom. But I don't know that without a picture, so I'm just gonna say 3/4 for both of those. How about B? -1. Yep, -1, because you have negative x over x. All right, here we go. How about C? Now, C is kind of wonky, right? Simplify the first 2 terms there, and what do you get for C? You get y equals what? -2/3 x squared. Now, what shape is that? Yep, that is this, right? As the curve, if I were graphing this problem, it will approach its end behavior asymptote. So as I go to the left, what's it doing? Negative infinity. And as I go to the right, what's it doing?
Negative.
Negative infinity. If you have a non-horizontal end behavior asymptote, the curve's gonna act just like that asymptote. So if the asymptote's down, down, the curve's gonna be down, down. Now, there'll be a whole bunch of other stuff in the middle of it for sure, but that's gonna be the end behavior. All right, what about D? same thing, isn't that one gonna be 5x? What does 5x look like? That. So on the left, we are going down, and on the right, we are going up. Okay, and here's the part I left out yesterday, or Sunday, that we need to include. All right, everybody okay with this as I'm erasing it? We're all right there? Okay, now, we know that for problem D, that's the problem we just did, we know the asymptote is going to be some version of y equals 5x. It could be a line, slope of 5, I don't know what else comes after it. In terms of the behavior, it doesn't matter. Every 5x line is going to look like that. But I want to know particularly, what is the equation of the slant asymptote for this problem? It's very easy to find, and you did it last year. Well, you did the operation last year. Do you remember synthetic division from last year? Synthetic division? So out here in a little box, I'm gonna put a 3. Because out here in the box, you don't need to use a box, I use a box, you may have used something else. But out here, I'm dividing by x minus 3. So I put a 3 there. If I were dividing by x plus 2, I would put a negative 2 there. Then I write down in descending order the coefficients of the thing I'm dividing into, the divisor. No, the dividend, the thing I'm dividing into. Okay, notice the 0, very important. Bring the 5 straight down, and then we start multiplying. 3 times 5, 15, add. 3 times 15, 45, add. Remember that from last year? I'll be doing a lot of that in the not too distant future. What's that mean? Okay, this is what I started with. What does this now mean? What is this?
5x squared 15x minus.
Not 5x squared, 5x plus 15, and then that guy right there is the remainder of the division problem. Remember, you're dividing, guys. If you divide an x into an x squared, aren't you going to be left with an x? The power goes down by 1 because you're dividing. We disregard the remainder. There is the equation of your slant asymptote. I know most of you, maybe all of you, have turned it in. There were a couple in the homework. I just want to do another one with you. There was one in the homework that looked like this. And your job is to find the end behavior asymptote. Now, if you said y equals x, you're on the right track. You know what you're talking about, right? Because the curve's going to have that behavior. But if we actually want to find the asymptote now, the actual whole asymptote, we'll divide. So what will go out here in the box? 3. And then across the top, 1, negative 9, and 1. And then the 1 came straight down. So we have 3, add, and add. So what is my answer? What is the equation that comes out of that? Y equals x minus 6. Remember, we disregard the remainder. There's a remainder, guys, Because is the thing ever gonna touch its asymptote? No, so this is what's keeping it from actually touching it. We don't need that when we write the equation.
So would -6 be the y-intercept?
Of the asymptote,
That's-
not of the curve itself,
Okay.
but of the asymptote, yeah. Yeah. Everybody okay with that?
Wait, so like y equals x minus 6. That's the asymptote, that's
Yeah.
not the line?
Yes.
Okay.
Well, it is a line, but it's the asymptote,
But it's not like the.
the curve. It's not a
Yeah,
picture of
okay,
this, no.
Okay.
It would be, so it's gonna look like this, right?
Uh-huh.
That's gonna have a vertical asymptote at 3. Oh, wait a minute. My vertical asymptote over here. Let me start over again. So my vertical asymptote's at 3. My slant asymptote is right here.
Mhm.
I don't know where my zeros are, and I don't wanna take time to find them. I know my y-intercept is -1/3 for the picture itself, right?
Yeah.
So, when I draw this thing, whatever it looks like, and again, I don't know what it looks like, cause I haven't found the zeros, but a possible picture would be this, approaching its vertical asymptote there, and its horizontal, or its slant asymptote here. And then over here, I might have this, the other piece of it, approaching the slant there and the vertical here.
Wow.
That's what they look like. All right, and then number 5, this was from yesterday, or someday. What's the first thing you're gonna do with this guy? Factor it. And what do we notice? It's an inequality, we're not graphing it, but what do you notice?
Not
There's
all.
gonna be a hole, we can actually cancel. Now, here's the scoop. We're not like graphing it like this, but on your number line at 3, you have to put an open dot. Because even though that's going to leave the problem, in the original problem, which is what you are solving, could x be 3? No. So that's gonna be an open dot on the number line. You're gonna have another open dot on the number line at 1, and a closed dot on the number line at -3. Everybody okay with that? Remember, dots that come out of the denominator are never closed. They can't be. Everybody good? These are the 3 dots in the problem. This is what you need to plug into though. This is when you do your sign chart, you can do this. You don't need that. You can use this right here. So -4 would give me negative over negative. Does that work? No. How about 0? 0 gives me positive over negative. That looks like that works. How about 2? 2 gives me positive over positive, no. And 4, So it looks like the answer to the problem is just -3 to 1, is that good? This didn't enter into it, but I want you to be aware that if you cancel a factor out, you have to include that in the answer on the number line. Okay? All right, let's look at this picture now on this next page. And what is the limit of the function as x approaches infinity? Look at your picture. It's right there. what is happening to your y's as you head off the page to the right? It's approaching what? 1 from the top? What about as you head off the page to the left? 1 from the bottom. Perfect. Now, this is kind of new and unusual. What happens as x gets closer to -1 from the left? Remember, this is an x value. Okay, so I'm -1. You can either come at me from the left or you can come at me from the right, right? So this says, what happens as you get closer to -1 from the left? What are your y's doing? Going down, negative infinity, that's exactly right. As you approach a vertical asymptote, kids, what has to happen? You either gotta shoot up or you gotta shoot down, because you're not crossing it. Right? It's like a roadblock. You gotta go one way or the other, and on the left, we're going up. What are we doing coming in from the right side of -1? That's going to positive infinity, isn't it? Alex?
Can you cross like a slit asymptote or a quadratic asymptote?
Yes, in the middle. They're just like regular end behavior asymptote. But at the ends, so down here and up here, or whichever direction it's going, you're going to approach it. But yeah, they are end behavior asymptotes, so they can be crossed. All right, take a second and do problem B. Fill in all those little pieces to problem B. So these two that I have arrowed, those are the end behavior. Can you recognize that? We're heading toward infinity and negative infinity. So end behavior, what happens on the far right side of the picture? The far right side, we're getting closer to from the bottom. And on the far left side, I'm doing this one now. Far left side, same thing. Now, what about all the rest of these? Well, -2 is a vertical asymptote. And this says, what do I do on the left side of -2? Well, what do I do on the left side of -2? Negative infinity? And on the, wait, this is the left side of +2. left side of positive 2 is positive infinity. Right side of negative 2, did you say positive? And right side of 2 is negative. How did you do with that?
Flawless.
Okay, flawless, flawless, love it.
Oh yeah.
Okay, let's do the last one, C. Same exact thing, different picture.
That's on the left side of it, that'll be a horizontal, not
Just hammer with some I like this. I know how to do it.
Okay.
No.
All right, who is willing to, just so we know, I need label them. So let's just label here, 1, 2, 3, 4, 5, 6. So 1, 2, 3, first column, 4, 5, 6. All right, who's willing to share your answers then? All right, Declan, what do you think? Number 1. So -2 with a little plus sign up there, everybody okay with that?
Yeah.
Declan, number 2. Negative infinity. I see some nodding. Number 3. Positive infinity. Number 4. -2 from the bottom. Number 5. What'd you say? Positive infinity. And number 6 is negative infinity. You got it? Okay. I just turned back some homework. A few of you had turned things in early. Are you good with what I turned back? Have you figured out? Do we need to talk about anything? You've all turned that in by now, but not all of you have it back.
Are you circle the ones for the and you give your asymptote or slant? Is that because I didn't have like the whole thing?
Yeah, but that's not your fault. I had to show you how to do it. Now you can go back and put the whole thing in, right? Yeah. And we only do that for slant asymptotes. So the other ones, the weird ones and all that, we don't do that for. You could.
Really hurts.
I took, for the, what it said, the NBA, I put both the NBA and the asymptote actually was, is that okay?
Yeah, but literally, the end behavior asymptote is y equals 5, you know, something. Yeah. Okay. All right, let's get our notes out then. That's a good little recap there. Let's get our notes out. And now we're going to spend some more time with vertical asymptotes and poles. 1.9 to 1.10 to kind of put this all together. So here we go. Well, we already talked about everything on the page. So let's skip to example 1. For each function below, determine the x values of any holes or vertical asymptotes. So we're on example number 1. How do we get a hole? We cancel. Holes are, the official name for holes are removable discontinuities. They're graphed as holes, they're discontinuities.
Do you have extra copies of the notes packet?
Maybe, so we're gonna be on our thing back there.
Are we gonna have to know that name?
You should, because you're a math student. Alright, so we're gonna have a hole, and he only asks for the x coordinate. So the x coordinate of the hole would be -3. But if you're graphing it, like we did a minute ago, you're gonna need to know where to put that point. Open dot, so where are we gonna put it? Well, we'll take that -3 and put it in here, so we get -5 over -8. -3 comma 5/8, is that okay? He only asks for the x coordinate, that's fine. But if you're gonna graph it, you need the ordered pair. Do I have a vertical asymptote in this problem? Yes, I do. My vertical asymptote is where? X equals 5? Now B. Look at this one. This one's a little crazy here. Do I have any canceling going on? I surely do. This thing can be reduced down to this. Did I cancel appropriately? Now, you might think that because you really canceled out 2 different parentheses, that you're gonna have 2 holes, but you don't have 2 holes. What do you have at -1, kids? It is not a hole. What is happening at x equals -1? Vertical asymptote. I don't care if you canceled out or not, you are left with it in the denominator, so it is a vertical asymptote. Think about this for a second. If it's a hole, aren't you supposed to be able to plug -1 back in and get a y? Can you? No, it's a vertical asymptote. Now, do I have a hole where x is 2? Yeah, because I canceled it out, and I can plug it back in. What do I get when I plug it back in? 0, that's fine. Alright, is everybody good with that? 1 hole, 1 vertical asymptote. Alright, what about C? Let's factor, what do I have down there? X squared plus 4? Do I have any holes? Nope. Do I have any vertical asymptotes? X equals 0, yep, just 1. Because that will never equal 0. Well, with real numbers, that will never equal 0. So we have 1 vertical asymptote, no holes. Alright. Let's do one more. Write a left and right limit statement as x approaches 2 for the following functions. How in the world are we going to do this? First of all, if you were graphing it, you'd have a vertical asymptote at 2. So as you approach 2 from the left and from the right, what is your picture going to do? One of two things. As you get closer to it, it's either going to go up or it's going to go down, right? You need to figure that out. Any idea how we might figure that out? Plug in. So maybe you plug in 1 and 0. And then maybe you plug in 3 and 4. And what's going to happen? Well, if I plug in 3, I would get a number. And if I plug in 4, the number's lower, then that would tell me that I'm shooting up. I don't know because I didn't actually plug them in. But it's got to be either going up or down. So your 2 dots, one of them is going to be bigger or littler than the other one. Well, we will continue this browsing discussion next time. No office hours tomorrow. Instead, office hours